CEO of YasMoney.io. We're a fintech focusing on crypto and payments within the African diaspora. Nick.
And my name is Nicholas Williams. I'm the VP of software for Devio. We're an innovative new crypto company that has a different approach to blockchain that I'll expand upon in a moment. And we have a lot of touch points. It's kind of hard to understate the amount of changes that blockchain could create in the world. Did you have a question?
Yeah, so I guess we can get started just with the basic question. What is it that you do at Devio?
Devio, yes.
Devio, yeah.
So I'm actually one of the lead developers. I've designed most of the system personally. I've written probably at least half the code in our core system. And it's a unique take on blockchain compared to what a lot of other systems that are deployed right now do. And I mean, there's a few ways we could approach it. Do you want me to talk more about Devio or like
what you've done there and
okay.
Yeah.
So we took a whole new approach to things that we call proof validation. There's two. I don't want to get too technical, but there's kind of two main approaches to consensus, and that's the process of actually agreeing on one unique chain in a system. The main two are proof of work, which Bitcoin is kind of the standard of that, and then proof of stake, which is how Ethereum approaches things. And we have a completely different take called proof of validation. The key aspect to it that makes it unique is that it's deterministic. And these other approaches are completely non-deterministic. They use things called nonces to basically create entropy in the blocks and uniqueness in a way. So in Ethereum or in Bitcoin, the minter or the node that creates the block has a lot of flexibility about how they order transactions, how they include or exclude transactions, how what metadata they put on that. And in Devio, we actually try to eliminate that altogether. We create one deterministic process of creating a block. And this leads to a situation where a bunch of nodes working in parallel get to this kind of what's technically called an embarrassingly parallelizable problem, where they can all work independently and arrive at the same answer because there is only one answer. And so that's actually, there's some interesting edge cases and a lot of technical details to it, but that's the essence of what makes it so unique and so fast. We can, if anyone's interacted with Bitcoin ATMs or, transferring Ethereum, that there's a huge amount of variability in settlement time. It could be seconds, minutes, hours even, sometimes if the network's really congested. Our system is designed to settle very rapidly, usually in sub-second times. Basically, network latency is, the only thing slowing things down at all. So as long as the network is, and I don't mean like the network in terms of transactions coming into our system, I just mean, the network in general, getting something in the pipe from Europe to America. As long as that is clear and fast, then settlement is extremely fast. And it's actually that determinism that makes that possible.
And how does that compare to Solana?
I don't know a ton of details about Solana personally. In fact, I think, are they proof of stake? No, you don't either. Yeah. So yeah, no, I can tell you everything about Devio that, it's complex, but I'm not super in depth on all the other chains that exist today. So in my opinion, I think people sometimes think that like with proof of work and proof of stake, like consensus is solved or something. I don't think that at all. I think that there is still a lot of potential for innovation kind of at that fundamental layer, and it can make massive differences kind of, especially as you scale things and roll things out. So in our system, for example, because we have that efficiency of speed, we have lower costs. It goes back to that last discussion you're having in terms of data centers. We don't need as many nodes to secure and run a network because a relatively, compared to Bitcoin or Ethereum, a relatively small number of nodes can all produce the same answer, and they all have to get exactly the same answer. If even one bit is flipped, they're not going to agree. So through that process, there's just a lot less overhead required, and so it uses less energy and it's more performant. So we kind of get the best of both worlds in a lot of ways there.
So does the transaction happen on the device itself or on the nodes?
All of them. So
all of them.
All the live nodes, and so this is where sharding comes in, because there's kind of another layer of abstraction where, in Bitcoin or Ethereum, you have this one chain, and so it gets to be a very large chain over time. You could think about Devio a little more like if you've ever made rope, you take multiple threads and you weave together the rope. So each individual shard is a blockchain in itself, with all those properties you expect, like immutability. You can't front run it or anything like that. But they're also composable, which means we can put different chains together into a larger, more abstract chain. And so in that way, you don't need every validator or node in the world to participate. You only need a subset of them for that shard. And so, there can be a relatively small number of validators running each shard.
Okay, so what type of applications would this be useful for?
Many applications. If we step back and look at kind of the big picture, with just the concept of blockchain in general, I guess I want to make a clear distinction. Everyone, I think, likes to focus on consensus, because that's kind of an interesting and important process. But just the structure of the blockchain as a piece of data itself is where a lot of the value is, in my opinion. And what I mean by that is it's the self-referential structure that is tamper evident, that you can do error detection on kind of just organically. And I think that has major implications for many industries, things like supply chain and accounting in particular. If we take kind of a really broad historical look, I think there's very few technologies that create a similar phase transition to this. The ancient one would be writing itself, right? Like making a ledger in stone or on papyrus or whatever was a big breakthrough, and I think probably changed the economies of ancient worlds. Then more recently, you have the advent of double entry bookkeeping, which kind of was hand in hand with the advent of corporations and stock markets in kind of the 17th century. I think blockchain and eventually things like DAOs and stuff are a similar phase transition to those things, where it's such a massive wave that I don't think the full implications aren't going to be realized in, a decade or even several decades. Like it is going to be, it's going to touch so many things that it's going to take longer than that, because really what a blockchain is a chain of evidence. Mm-hmm. So if you have any like series of events or accounting or, anything you want to track and you want to know that it was not corrupted, it was not tampered, this data structure gives you that. And that is huge. So, I could go into more detail in a number of industries. Like
let's get into more detail.
In supply chain, for example, you have the kind of disruptions we saw during the pandemic, where a lot of companies go with more just-in-time supply models, and so all of a sudden they're cut off from their supply. But there are various competitors around in their industry, right? So theoretically, and in some industries it'll work better than others, but in like a textile industry, for example, if you have some inputs, you need fabric, you need needles, you need machines, parts for those machines. They're all fairly similar and interchangeable. Normally, competitors would not have any ability to share those, right? But with a blockchain, you could set up a market where they can, when they have some kind of stoppage like that, they can offer for exchange things that they have extra of for things that they're missing. And so thereby more localized markets can overcome those supply disruptions to some extent and keep operating. So even in normal conditions, it could lead to more robustness and better, I guess, lower volatility in terms of the price of inputs.
And I suppose this could affect the price of the actual commodity itself.
Absolutely.
So would this be useful in a commodities exchange?
Oh, yes. And that's actually one of my main interest points and where we're headed in kind of the relatively short to medium term is being an engine for exchanges.
That's very interesting because we actually building a commodities exchange in Africa, and we're still searching for a partner to work with. So maybe
Great.
we could talk together.
Yeah. Well, and yeah, we've already. I mean, we
Yeah,
already
we've spoken
connected
about
over
that, yeah.
email. Yeah.
But yeah, I'm just plugging in Yaz money.
Yeah. Well, and that's part of how I got into
Yeah.
it. As I've always been interested. I think a lot of the problems that the world faces today, especially in terms of things like climate change and things, a lot of it is externalities. Like, if we could somehow bake those challenges into the accounting of major companies, the profit motive itself would push us to solve those problems better. If right now a company can just release all kinds of gases into the air and it doesn't matter, right? That doesn't hit the books at all. And so kind of from that thinking, I've gotten really interested into, credit systems like carbon credits, solar energy, SRECs, things like that. And there's some more exotic credits that people are thinking about as well. Those could have, I think, a massive effect in terms of just changing the calculus of how businesses decide what to do next.
So what is the difference between like a solar credit and a carbon credit?
So they're just measuring different things. A solar credit is relative to solar energy produced and used somewhere in the world, and whereas a carbon credit is specifically attached to an amount of carbon kind of avoided from releasing or ideally absorbed, right? Like if you plant a forest, that forest is, and it doesn't die, that forest is going to grow and absorb a bunch of carbon, and so you can generate credits from that. But there's a lot of problems in that space right now. Those credits are massively undervalued currently, partly because it's mostly voluntary, where organizations don't really need to use them. They only do it, kind of for greenwashing, kind of just to make everyone feel good. They're not really seeing kind of the bigger picture of how it actually might benefit them in the long run. And so, there's still a lot of work to be done there, but I think it's a really interesting challenge. You have a question?
I do. So I'm actually very familiar with this particular thing, particularly in the solar sector.
Mm-hmm.
One of the concerns that was proposed was really tracking all of these things, solar credits, carbon emission credits, whatever else that's going to be added to it. How are you going to be able to track all this, right? Like, is there a centralized platform that's going to start aggregating all this?
No, decentral. That's where the blockchain comes in, and that's exactly what led me to be really excited about developing this. Is it can't be centralized, right? Because that leads to a lot of ways for things to be tampered with or just lost accidentally. It has to be decentralized, and so you need something that's both decentralized and, in my opinion, deterministic. Because that way everyone can be sure that this is the record. Now, that's not to say it has some kind of special intelligence. Like it is very much like chiseling something in stone. You put something down, and as long as there's no chain break, as long as you can calculate all the hashes, nothing has changed. So you have veracity that the record is consistent. You don't necessarily have veracity that the record was initially correct, right? It doesn't avoid analog holes. It doesn't avoid people doing malicious things like you could have some kind of energy monitor where you're getting SRECs based on how much energy you're producing.
Sorry,
and if instead so that's just solar energy credit, SREC,
Okay,
sorry.
okay.
So say, for example, and this is just a way someone could maliciously cheat, is you have a power meter and you're using that to get credits, but instead of hooking that up to a solar field, you hook it up to a gas generator, right? Like, so there is still a need for people to go and inspect projects, make sure that, what they're saying is true, that their equipment isn't tampered with and things like that. But blockchain is kind of, it is a lot like writing or something, or, it's mathematics at the end of the day. It is just a way to show that these records are tamper-proof.
At least the entry of those data is not tampered with.
Whatever data gets entered is not tampered with. Exactly.
But the data itself could inherently be.
Exactly. And that's why, so some systems, one thing I think we do well is you have to be careful about rigidity. And, going back to supply chains, say that there's a delivery that's supposed to happen at this warehouse, but the driver gets the wrong address or something, delivers it to this warehouse instead. You need a system that can adapt to the reality on the ground. And so we've done a lot of integrations with IoT for that. If you have sensor networks reporting on what they're actually sensing in real life, then you have that raw data, whatever it is. If there's noise or errors in it, you can deal with that in the long run. You need a system that, even though the record is immutable, you need to be able to retrospectively say, like, oh, this record was actually mistaken. On block N, the record's created, block N plus 1,000. There's a correction to that record, and our system supports that.
So you mentioned IoT. You have IoT devices, and this is tracking solar farms or what is it?
A huge variety of things. IoT systems that track cold chain, where, say, food that's being shipped needs to stay under a certain temperature. So they will alert if the temperature rises in the truck, beyond the threshold, and that you can know that particular shipment is, potentially contaminated. So that's one example. The amount of air pollution or dust in a factory, which might be important for worker safety. Just the output of a solar farm or kind of any distributed power installation. We've even done worked with projects where there's wearable IoT devices that help with safety. For example, in a manufacturing facility, there's machines and robots that are moving around, and it'll track someone's location in that space. So the floor manager, or whatever, can see if people are walking into this area where a robot or something might come by and potentially injure them.
And that all goes onto the blockchain.
Yes, but their own blockchain. It's
blockchain.
not that. That's the big difference with
Oh, I
sharding.
see. Okay,
is
so-
there's not one big blockchain in the sky.
So you're almost like
there's one per factory.
like your own database.
Exactly.
Database blockchain.
And
okay.
that's really insightful. I'll get to your question in a minute. Data normalization is actually one of the most expensive operations we have in our system today. And so we still rely on databases like Oracle and Postgres for that. But I think in the long run, the blockchain itself, it is a data store. It's data persistence. And it's made for long-term data persistence as opposed to like an in-memory database.
And can't change it.
Exactly. Yeah. Did you have a question? Yeah.
Actually, it's in the same line of thought.
Mm-hmm.
What are the benefits of using blockchain to store all this information as opposed to just putting it in a database and preventing any editing of those records, just like a blockchain?
Mhm.
You can't go to N and edit that. You just have to make a correction on N plus 1,000.
Right.
Why not just use the database?
Excellent question. The question is, what makes blockchain better or different from a relational database in terms of securing data? Because you could, to kind of expand, and I think where you're going, you could have a record in a database, with backups, read replicas, and all that stuff, and you just sign those records, and so you can check that signature. Like computer science has been doing for decades and decades. You have a sanity check or just error correction. The difference is it's distributed. So, and kind of organically in the process of creating the blocks, you have a number of validators get copies of it. So you kind of automatically get disaster recovery for free. Where, in a big database, you have to do these expensive operations where you're writing the data over, and usually in most setups only one can be a writer at a time. In the blockchain, you can have many writers simultaneously, and you also get a current record that is very timely. So you get into stuff like with commodities trading. You could have a shard that is specifically tuned for high frequency trading, where settlement is very rapid, sub-second, and multiple parties have a view of that and input into it in terms of new orders at the same time. One of the biggest, I think, uses of this from like a corporate standpoint is distributed logging, actually, right? If you have a multinational corporation, you have events happening essentially at the same time at any given time all around the world. So with our system, you can create multiple shards, one for each region, one for each department, however they want to break it down, and have all those threads, all those chains going at the same time. And then for your overall analytics, you merge those chains, you compose them into one, more abstract chain, and then you can actually get this kind of global view of what's happening.
So this is pretty disruptive, because what you're essentially saying is that this could like kill traditional databases and traditional cloud.
I don't know, but I don't think so. I think it'll be additive, and I mean, in some ways, I think it will. It'll definitely break things off as a specific use case, but for certain like normalized operations, I think a relational database is still really good. And I mean normal. I don't know if you know what normalized means technically. Yeah. Okay.
Force normal form.
Exactly. If it's in the normal form, I can't read that. Can you? If it's in the normal form, relational databases are really good at that. A blockchain is a ledger, right? So it's a slightly different format. And here's actually key to it, especially in our system. It writes faster than it reads. If you think about it, right? Like you can put new records onto it very quickly, but if you want to like do some complex query with joins and stuff, that's hard.
Yeah, I mean,
so you actually kind of need to analyze it and dump it into a normalized database to do your analytics still.
Well, I mean, you're thinking about like a object database, like Mongo or something like that. There,
Exactly.
you could do something like that there, right? Like.
Oh yeah, absolutely. Well, that's the difference. It's not object oriented. It's more like vectors.
Yeah. Yeah, I mean that's it sounds amazing, and you built this.
Yeah.
Oh, congratulations!
Thank you.
Big, it's huge.
I mean, it was I have an excellent team behind me.
Yeah.
I'll give a shout out to Sean McKinney, excellent developer, Quinn Maloney, and Tom Anderson was really there with kind of the high level initial ideas, and I just took those and refined them and kind of made them a bit more mathematically rigorous.
Yeah, no, I mean that kind of all the different projects that you could work on. I mean,
and that's part of the problem right now is there's so many different places where we can have an impact. It's really hard to like stick to a small number.
And I'm just imagining Microsoft or IBM buying your company and just throwing it away because it could potentially impact a lot of different cloud providers.
Yeah, I mean, there's not really a way to do that. Once an idea is out. No, not currently.
Okay.
But I mean, the ideas aren't so complex. In fact, I guess as a system designer, I try to focus on simplicity. Yeah. So, I don't think, like, we do have some very, I guess, valuable. We have IP and we have valuable trade secrets and things like that. Yeah. But even if somehow that all got trashed, like, I think there's fundamental ideas there that are inevitably going to come out. If not by me, then by someone else.
So would you say that this is the future of database technology?
It's the future of distributed ledger technology.
Yeah.
And I think databases will still be very important.
Yeah. So distributed ledger technology.
Mm-hmm.
So right now, as it stands, Bitcoin, Solana, Ethereum don't really do what your system does? Like,
not at the cost and scale that we can.
Okay. And then you combine that with smart contracts too.
Yes, our approach to smart contracts is a bit different. We don't support Solidity, the language.
Okay.
And there's some pretty subtle technical reasons for that. But one of the big ones goes back to, I think, the panel discussion a few hours ago, is that you could do anything with something like that. Like you could make contracts for someone to like do bad things, to someone else, right? Like a smart contract, just as a procedure, is very unbounded. And so our system is much more transparent in a certain way. For example, one of the big differences between those systems and ours is we actually, on the base layer, we've sacrificed forward secrecy. So that means everyone knows what a transaction or process does by default. We can obfuscate that and encrypt it and make it hidden for privacy reasons if needed, but that's on kind of another abstraction. At the base layer, everything is transparent. It is very clear where everything is going. So it's a pretty different model from compiling things and having the EVM.
So I'm just thinking of, I used to work in e-procurement, built procurement platforms, one of the largest companies in North America. And I'm thinking about this technology working within government, and
that's going to be the ultimate. I think it'll have the biggest effect on government ultimately, but I think that'll take the longest out.
Because you have full transparency there, and putting everything on the blockchain with a particular database would reduce corruption within a lot of, even within North America.
Yep, and you're right that there's definitely people and forces out there that see that as dangerous.
Yes, that's very dangerous.
Mm-hmm.
But disruptive too, right?
Absolutely.
And if you open source it, maybe.
Yeah, I think in the past the decision was we were open source originally, and then we closed because we didn't want anyone to leapfrog ahead of us. Yeah. We're probably getting into a position where we could reconsider that.
Yeah, I think the technology is very powerful. Congratulations again.
Thank you.
Yeah. Any questions? More questions for the audience?
I think we're out of time.
I just wanted to add something on the question that gentleman had. When it comes to blockchain, the reason why it, on Nick said, why it must be decentralized is for that security of the data. It can't be. It's not changeable. Where everybody on the blockchain is checking into every transaction being put in and the information incoming. So if anybody malicious tries to attack the system, everything that's checking in would be able to attack that.
I can encapsulate that into a nutshell for us to
That
finish.
is a good point that you made, and I'm sure he'll be able
One
to
sentence.
address that in person in the break, and you guys can network and talk about that after the panel wraps up. Thank you.
Yep, you get disaster recovery organically.
Sorry.
Thanks.
Thank you to our panelists. That was a wonderful discussion. Thank you for your knowledge and input.